Let's look at example 3. Let x bar be the mean of a random sample of size 50 drawn from a population with mean 112 and standard deviation 40. We want to answer 3 questions. We want to find the mean and the standard deviation of x bar. We want to find the probability that x bar assumes a value between 110 and 114. And 3, we want to find the probability that x bar assumes a value greater than 113. Now, let's notice immediately we have a sample size that is considered large. It's considered more than 30, which means our central limit theorem applies, and we can consider this a normally distributed sample. All right, so with that in mind, let's answer these 3 questions. All right, so we're looking for the mean and the standard deviation of the sampling distribution. And we're going to use the formulas that we just got in this section for part 1. So for part 1, the mean of the sampling distribution is always the same as the mean of the population. So our mean of our sampling distribution is 112. Our standard deviation, however, is a little different. So let me go to a blank page, and we're going to say the mean of x bar is 112, and the standard deviation of x bar is, now let's go back here for a moment to our standard deviation that we had. It was 40, and our sample size is 50. So our new standard deviation is 40 over the square root of our sample size, 50. All right, so let's put that into our calculator. And that gives us 5.65685. I'll take it out a few decimal places here. In fact, I'll take it one more. All right, so we've got our mean and the standard deviation of our sampling distribution of the mean. All right, now that's question 1. Let's go to question 2. Question 2, we wanted to find the probability that x bar assumes a value between 110 and 114. Notice we're talking about x bar and not x. When we were finding probabilities for a normal distribution and we had x, we used our z-score, x minus the mean over the standard deviation. But now we're looking for the probability of x bar, of the mean itself. All right, and also a clue in our example is that we have a sample size. So we're going to use a z-score, but it looks slightly different. The formula we're going to use now is the following. We want x bar minus mu over sigma, our standard deviation, and let me put parentheses here, divided by the square root of the sample size. All right, well, let's fill in with the information that we've got from part 2. We're going to have to do this twice since we have 2 different values. So let me go back here. We want to find the probability between 110 and 114. Now we're going to use these z-scores in the same way that we did in prior examples. We're going to put in 110, convert it to a standard normal value, and then put it into Excel and see what the probability is. And we're going to put in 114, convert it to a standard normal value, put it into Excel, see what that probability is. And just as before, when we have the probability between 2 values, we will subtract them to get our final answer. So let's go ahead and convert 110 first. So we'll have z is 110. Let's realize that mu of x bar was 112 up here. And really, the bottom, we can take a little shortcut. Sigma divided by the square root of the sample size was exactly what we found up here. The standard deviation of x bar was 40 over the square root of 50. We already did this bottom right here. So let's just go ahead and put the whole thing in. 6, 5, 6, 8, 5, 4. I can't type apparently. And that is going to give us -2 on the top and still have this large decimal on the bottom. All right, and I'll put that into my calculator. And that gives me -0.354. All right, now let's do exactly the same calculation, but this time with our other value, which if we look back at the example was 114. So we will do 114 minus 112 divided by 5.656854. And of course, that's going to give us a +2 over this, which means I don't really have to put that into my calculator. I know that's going to give me 0.354. All right, so now that I've got both of those values, we want to look them up on Excel and then subtract the two probabilities. I'm going to start with the positive one because I know that will be the bigger one. So if we go to Excel and in any of the places we put equal, norm.s.dist, my z value was from back here, 0.354, and I want to put true, and I get a probability of 0.6383. Now I'm going to go ahead and put that back here, 0.6383. We know we're going to subtract off whatever we get for the -0.354. So let's go ahead and do that one. Equal norm.s.dist -0.354. True. And that's 0.3617. And subtracting these two probabilities gives us 0.2766. So there's our answer to question 2. Let's go to question 3. All right, so question 3 was find the probability that x bar assumes a value greater than 113. Now remember when we were using our probabilities before for a z-score and we had a greater than problem, we had to find the probability in Excel and then subtract it from 1. And we're going to do that here. But first we have to use our new formula to convert since we're talking about x bar. So 113, let's put it into the formula. So again, z is 113 minus 112 divided by that same standard deviation we've been using up above. And 113 minus 112 is going to be 1 over that huge decimal. And then let's put that thing into our calculator. That gives me 0.177. And I want to go ahead and look up 0.177 in Excel. But let's remember, we said we have to subtract this from 1 once we get it. So let's go ahead and look up 0.177. So I'm going to do equal norm.s.dist. And I'm going to put 0.177 true. And it tells me that probability is 0.5702. So let's go back. 0.5702. Let's make that subtraction and we'll have the answer. And that gives us 0.4298 as our probability for the third problem. And there we have it.